Hi, welcome back to How to Build Your Data Science Portfolio series. And in this series, we have been talking about how you can take existing data sets that are available in open source repository or even Kaggle, and then enrich it with additional alternate sources and basically make your data science portfolio stand out. So if you're not seen my introduction video, I would say like you can click the link on the top and check it out on basically how to make your both profile and portfolio stand out when you are building an data science experience or capability, right? So now coming back to in my last video, what I did is I basically covered the top part of it, the social media part of it. So for the coronavirus hashtag, we have been listening to social media and pulling out all the tweets that are coronavirus mentioned, and then we took it and then we cleaned the tweets. We did geo encoding of the tweets based on where the user is basically tweeting. We are getting an approximate exact location of the user. We did some sentiment analysis. We did some named entity extraction out of the tweets, and then finally we built a tweets data frame which has all the data. So basically we took the raw data and we created a lot of enrichment. Now, as in case if you have not seen that video, I would say click the link on the top and you can watch the link, watch the video to see how we can tap onto social media and complement the existing coronavirus data set that is available in John Hopkins repository. So in this video, we are going to focus on the center part. Basically, what we are going to do is we are going to pull the data from John Hopkins repository. Now, why John Hopkins repository? Why not Kaggle? Now, Kaggle data set is already aggregated and it's basically updated once a day or whenever the Kaggle member is going to update it. But the data in John Hopkins repository is getting updated across multiple times a day, and the data is completely raw. So we are going to use the raw data set and prepare the data set. Now, even the Kaggle data set and even the aggregated data set provided by John Hopkins repo is not perfect. There are a lot of empty values and missing values for province and state column. So we are going to see how we can approximate the province and state value. The first is we are going to take a raw data set, we are going to combine data frames, and we are going to build a final one data frame. And out of that, we are going to make sure that the state and province column, which has a lot of null values, we are going to fix it. When coronavirus started in China, basically the state and province was captured, and even in USA the state and province was captured. But when it spread across multiple other countries and location, basically it was aggregated at the country level because they may not have state information or something like that, right? So that's what we are going to do in this video. You'll learn a lot of data cleaning, you will learn a lot of data imputation, you will learn new alternate data sources or lookup sources or reference data sources that you will take and enrich the data set. So let's get started. So as usual, my I'm going to mount my collab drive in this, and this is the command to mount the collab drive. So basically I'm calling google.collab import drive, and I'm mounting my drive. The reason I already mounted my drive, the reason I'm mounting my drive is I have a properties file, and the properties file are like common properties that I will use in my program or something which I want to secure it rather putting it in the notebook. I don't want everybody to see some of my passwords and access keys. So that's why this property file is. So this property file is available in my Google Drive. And what is this property file? It's nothing but a key value pair. I mentioned that in my last video also. It has access to my Twitter keys and also Google API keys. The Twitter keys is to pull record from the Twitter social media. I'm not going to use that in this video, but I'm going to use the Google API keys, which will allow me to do the geo encoding, and I will show you what is that. So in order to read the property file, I am going to install a component called config parser. So the config parser is basically going to take this property file and give me the keys. These are keys, and these are stored at keys and values. If you are familiar with Java or any language you have been using, you may already know about properties file. So I'm going to use the same concept over here. I'm importing pandas, I'm importing config parser. I'm defining the config parser as raw config parser, and then I'm telling my property file is in my drive location. It's twitter.properties, and then I'm just printing what section is available. I have only one section, that is Twitter, and within Twitter all these key values pairs are defined. Now what I'm going to do is I am going to go and import my data set, import my basically coronavirus data set. Yeah, this is the coronavirus data set repo, GitHub repo, which is getting updated intraday. There are multiple folders. One is there's a time series folder, and second is the daily report. The daily report is aggregated data, which is very similar to what is available in Kaggle. And this time series is basically more kind of raw data, right? So it has three files. You have the confirmed file. These are the confirmed cases of coronavirus. There is an recovered file with the cases that are recovered, and there is finally an basically now how much people like died from coronavirus. Three files are there, and if you see this is a time series file, you will have the province, you will have the country, you will have the latitude, longitude, and you will have one column for each date. Like that, you have three different files. One is the confirmed, second is the number of deaths, and third is the recovered. So we are going to use all three files, and we are going to concatenate the file. We are going to merge the file and create one final data frame, which looks very similar to the Kaggle or even the daily summary provided by coronavirus repo. That's what we are going to do. So what I'm doing is I'm first importing the confirmed cases. So I'm just giving like pandas.read CSV and the GitHub URL. The GitHub URL, basically you can see the confirmed cases. So what am I'm going to run this, and then I'm going to show one by one. This is the confirmed cases. If you see the head of the record, you can see basically you have the province, country, latitude, longitude, and a time series data for all the day up to the current day. As this updated in real time. So if you have some process to quickly refresh this file on a daily basis, or once in 6 hours or 12 hours, and refresh your dashboard, you may always see some live events, right? So this is the coronavirus confirmed cases. Similarly, I'm going to import the death cases, and if you see the death data frame, it's almost similar. Only thing, the count will vary. The recovery rate is pretty good. The mortality rate is pretty less, so that is good for this virus. So while the virus is going on, one thing is like it does not impact everybody, right? It impacts people with existing respiratory problem or old ages. So let's hope like we get past this virus soon. So these are the recovery cases, and this is the recovery head basically. So I'm just printing the first few records, and it's similar to that. So these are the recovered cases, and you can see like all the three formats are same. Just the numbers are different. So these are the recovered, and the recovery rate is also pretty good. You might have already seen video. Just make sure you wash your hands. You kind of don't touch your face. I'm just telling as a general precaution. That's not required for this particular notebook, but just want to call it out. So what I'm going to do is, now I have the three data frame. I have the confirmed data frame, I have basically the death data frame, and the recovery data frame. Now I'm going to convert this time series data, flattening out, and convert it into more columns. So rather than having like one row for each province and date, I'm going to say like, okay, 122, 133, I'm converting it into a row for each particular date. So that's why I'm using a pandas melt function. The melt function will take all the keys on which you want to basically, it's a kind of a think like a group by. You are giving a column, and then you are telling melt the remaining from, convert the rows into columns. Sorry, yeah, convert the columns into rows, right? So that's what melt does. So if you see the output, you will get to know. So basically I'm calling the melt function, and if you see over here, basically the entire row is converted into columns now. So now 122 is not a column anymore. It is basically an the row over here. Like that, for each country you will have 122, 123, 124. The dates will be arranged till 310 today, right? And it creates two columns, variables and value, which does not make any sense. So what I'm going to do is I'm going to rename the variable column into date column. It's a date column, and the value column into the confirmed number column, because it's a confirmed data frame. That's what I'm doing over here. And if I quickly run this and see, you can see the date and column name has changed over here, right? Next what I'm going to do is I'm going to do the same thing for the other two data frames. So here I am melting the death data frame, and I am renaming the variable, and then I am printing the output. So if you see over here, again, you have the other data frame also. The final data frame is recovered data frame. I am again doing the same thing. I am melting the columns, but rather than creating rename function separately, I've just given rename as part of it. Okay, so that's what I've done in this. And once I do this, you may find the recover data frame is also similar. So now I have all the three data frame. Now what I'm going to do is, for each of this province, country, latitude, longitude, and date, I am going to merge recovered, confirmed, and death cases into one single data frame. And that's what exactly the Kaggle data set and the other daily summary data set is about. So for that, what I'm doing is I'm creating a list of data frame. I have three data frames. I'm creating a list of data frame. And in the list, I'm setting my index as province, state, country, latitude, longitude, and date. So basically those are my index. And then I'm going to combine the three data frame based on that, and I'm going to join it in the third column. So basically once I complete this, you can see all the data frame is combined into one data frame, and you have the confirmed cases, death cases, and recovered cases. And you have these as the index, because that's what I set the index on the top. If I don't want the index, I can just do a reset index. So now if you see from the index, it becomes regular columns. So this is the data frame we are going to work on from here on. And before we work on, I just want to kind of do a few more column changes. I just want to make sure my latitude, longitude, and date, latitude, longitude, confirmed, death, recovered column is basically numeric column. So what I am doing is I am taking this and I'm converting it as to numeric. I'm just doing an apply function and doing it to numeric over here. So I'm taking the combined data frame, doing it to numeric, and then the date column, I want it as a date time, and so I'm applying a date time data type. By default, everything will be an object. So I want to convert it, and that's what I'm doing here. I'm converting it to an date, time, and numeric value. And then when I print the data types, you can see basically the first two is object, then your latitude, longitude as float, and then remaining as int. Right, and the date time as date. Now, if you see the output is not going to change, but just that, like, now we have the data type in place, right? And then I'm also going to rename the columns. The province, state, I'm going to put it as state, and then the country, region, I'm going to put it as country, and that's what I'm doing it over here. So I'm taking the province, state, I'm renaming the column into state, and then I'm taking the country, region, renaming the column into country. Now the province and now for some of the region like USA, the province and state will have both the city and state, right? We are going to clean that as well. But that's why they have given province slash state. In some cases, you don't have state. So data is not completely consistent over here. In some cases, the country is given in city. You can see a lot of scenarios in this data set. And it's a very good data set to really test your data cleaning and data preparation ability, right? So before going there, I want to check if there is any null. And if you see, like, okay, country does not have any null, only the state has null. So as I said, when this data set was created, China, basically the cases were tracked, yeah, at a city level, but as at a state level. But as and when it progressed to other countries, basically it was done at a country level. USA is done at a state level as well. Okay, so you are going to see, like, all aspects of it, where, like, state level and everything is going to be there. I'm going to show you. Let's quickly see, like, how much count is there on the data frame. As you can see, others are around 1700, but only the state column is 11760 because the null columns are ignored. And what we are going around, like, 5000 odd columns are null. Now let's start working and start imputing the null values. And it's not that we are going to randomly impute it. We are going to put some logic and then impute it, and it's not going to be a one-step imputation. So I'm just quickly checking it, taking one country and checking. You can see India, for example, country is there but state is null. The latitude and longitude is completely same for the entire country. So basically it's not basically tracked at the state level. It is tracked only at the country level, right? Similarly, you can see, like, what are all the countries. What I'm doing is I'm taking this confirmed df.state is null at a country level and doing a value counts. So this will show me all the countries where null data is there. And you can see around 107 countries are there which has null data. And like your Pakistan, Malaysia, Costa Rica, Cambodia, Gibraltar, you have a lot of countries which has null data, which is not tagged at the state level, right? So what we are going to do, first thing is we are going to see if we can impute by latitude and longitude. So we have the lat and long column. So we are going to take that, we are going to get the address, and we are going to impute it. Now that will not impute everything, but we are going to try that first. So what I'm doing for that, I'm going to use the Google Maps API, and I have the API key for that. And if you want to try Google Maps, you can go to Google Cloud Platform, and you can go to API and services. You can just register. You get a first year $300 credit. You can just go and register. The other option is like, even if you register it up to around some number of calls, right? Up to around even 100,000 calls, and some APIs are free on a daily basis. So you will not, for the testing and all, you will not end up paying anything, right? So you can go and register it, you can get it. You can go to Google Cloud Platform and register and get that API key. I have kept the API key in my properties file, which I loaded on the top, and I'm going to get that API key and assign it to an basically I'm opening a client connection, Google Map client connection, and assigning it to a Gmaps object. So, okay, Google Maps is not designed, so let me first run the previous step. Yeah, I forgot to import. Okay, now I have imported it. And once that is, let me run this and let me talk on this. Now once that is done, what I am doing is I am doing a reverse geocoding. So if you see in my previous video, what I did is I did a geo encoding, that is a forward geo encoding, where I am giving a state, city, or part of a address to find out complete details. But now I have latitude and longitude, and I want to find the details. I have to do reverse encoding. So this is what the reverse encoding does. Pass the latitude and longitude, call the reverse encoding, it will give me a result. Once I print the result, it will give me a big JSON object. And from the JSON object, I'm getting the formatted address. The formatted address looks like this. It says like, okay, Pozo, Colorado, Villa Ace, and Paraguay. So it's in Paraguay, right? And from that, I'm taking the second column, which is a probable state. Right. So what I'm doing is I'm splitting by comma, taking the last but two value, and I'm stripping any spaces, and I get the Vilayas. So this is the same thing I'm going to do, and I'm going trying to impute the value. And what if I first going to do is I am also going to create a function to make sure that the input data that is coming from the Google Cloud API, the Google Maps API, is basically ASCII character. It's not foreign characters. The reason I am doing it is like, when I fire this query in Google Cloud, if it's in Japan, it may show local language in a lot of cases. So I don't want to import with local language, because if I'm going to use this with any tool like Tableau or ClickView, they may not have all the geo encoding in place. So I want to make sure it's in A to Z character. That's what I'm doing. A first one, it's an English check. Then I am passing the latitude and longitude. Now the Google Maps API reverse encoding might fail if it is not able to find the latitude and longitude. So what I'm doing is I'm putting it within a try except block. And if it fails, it will come here. And what I'm telling is I'm just printing for the sake of error in reverse geo encoding, and just putting the output object as TBF, to be filled. That means as we go in, we will fill it. Now, if it returns the value, I'm going to like kind of split it by space and check whether the space is greater than 1, right? And then I am basically if it's see, basically what I am doing is, if that is an space character after the stripping, like, so if in case of India, the geo encoding has a problem, it will give the country and the zip code together. So I don't want that. So if when I do a space and split greater than 1, that means if it has more than two words, then I'm going to put it TBF. I'm going to do a different way of imputation. And similarly, if the English check match fails, I'm going to put a TBF. So wherever the data is there, it will get filled. Wherever it is not there, it will just put a TBF over there. So now what I'm going to do is I'm going to create one additional variable in the data frame called state underscore cleaned. And I'm going to basically take the state column, which is where it is null. And then I am see, basically what I am doing is I am taking the wherever the state column is null, because in most cases the combined DF already has state value. So wherever it is null, I am taking the latitude and longitude value, and I am applying a lambda function, which is my basically on the top. I have this function called get state over here. I'm calling this function with the latitude and longitude value. That's what I'm doing it over here. I'm passing the latitude and longitude value. So it will go there. It will go to Google Cloud API. If our conditions are met, it's going to fetch the data, and then it's going to populate in the state underscore clean data frame. Basically that's what it is doing over here. It's going to take some time. It's going to go to Google Cloud API. It's going to run for each column, and then it's going to give back. right? Now if you see, there's a lot of error in reverse geoencoding. That means for the latitude and longitude, it's not able to find a proper value. Now these are the cases we need to go back and work again there. And what I have done is, that's why I've created separate column. I don't want to work on an existing state column which is coming from the source, so that's why I'm creating an additional column over there. So we can see a lot of failures, but some values are coming. I have not printed the genuine values. I have printed only where there's an error. That's why you are seeing an error. And for every call, it goes to the Google Cloud API. If you go there and refresh the dashboard, basically you can see the number of traffic that is making and all this information. You can view your Google Cloud platform. Just make sure that you don't exhaust your daily limit in the Google Cloud platform. Otherwise, they will charge you heavily. So use it for the only purpose of testing. This is my personal account, so that's fine. I have limits. If I don't have limit, I may have to pay them, but still it's not very expensive. Even in a lot of projects, you can use it in real world project. So let get this completed. I think the API connection is slightly slower. It's taking around zero point 0.8 second on an average for each call. So once this is done, what I'm going to do is, I'm just checking by country. Now, what is the value count after it's cleaned? The column is cleaned. So what is the basically what is the distribution of nulls here? Now what I have done is, I have not merged the actual value over here, right? I have just kept the values as it is. So I will start merging the actual values at this stage. Now it's completed. Now if you see the output, it's going to show me even more error. Like, see, US has 94457 cases, mainland China has 1519 cases. The reason is this: the state level information for this was captured, and it is in the regular column state, not state clean. Now I have to merge it. So to start merging, what I'm going to do is, I'm going to create a copy of my data frame and create an intermediate data frame. So why am I doing it is, now when I want to build it, suppose I do some mistake, I don't want to start from beginning and again call the Google Cloud API. So we always do a mistake and the data frame is corrupted. We have to start from beginning. So when I do this copy, my combined data frame is stored at this level. Whenever I want, I can run the program from here. Now remember, if you don't give a dot copy and just give combined data frame is equal to okay, just kept int intermediate data frame, it is actually, it will update the combined data frame also if you don't give a dot copy. The reason is, it is going to just create a reference of it. If you want to copy it, you have to give dot copy, and that's what I'm giving it over here. And I'm just going to print wherever it is not na. So if you see, right, for the first thing, what I'm going to do is, so wherever state cleaned is not na, right, I have filled either tbf or the actual value I'm getting from the Google Cloud API, right? Google Maps API. So if you see, this I got from Google Maps API, this I got from Google Maps API, this I got from Google Maps API, based on the latitude and longitude, and I have filled the values for the latitude and longitude, right? So let me do a count, and you can see earlier the state was around some 760. Now the state clean is only 520, 5243 not null. The reason is, I have not merged the value yet, right? So let me first go and merge the value. I want to quickly show you the different output that we are getting. Now in this case, when we put the state column, the not state clean, the state column, and do a not na, if you see, these are the values where the values are there, but the state cleaned is not there. So this is what we are going to merge, right? Because these are genuine values that is coming from the file, and we are going to merge it. But see, this case in US, basically it has both the province and the state as well, not only the province or state. So we may have to do some cleaning of this as well as we go. That I will come to it next. So first, while I'm seeing this, let me start merging the data frame. So in this, what I'm doing, in the state cleaned column, again I am telling, if this state column is not null. We saw the lot of value, the state column is not null, right? I'm telling you the state column is not null, then basically replace in the state cleaned column state value, else keep the value of state cleaned as it. It's just a if else condition. If the state value, the actual state value is not null, then move the state value to the state cleaned, else keep it state cleaned. That's what I'm doing it over here. I'm applying lambda function, and now let's see the output after I apply the lambda function. You can see now wherever the state had not null value, the state cleaned also has not null value. So now the data frame, I have copied the state existing state value to the state cleaned value. Apart from that, I have also imputed value using the Google Maps API in some cases. Now I'll just print wherever I have to be filled, right? These are to be filled. Now if you see the to be filled cases, all the state are empty. Right now, how can I impute the state cleaned value if all the state are empty? I don't have any option, right? So now what I'm going to do for in this case is I am going to go to a new data set. I'm going to use an country capital data set. So this is just showing the basically the countries where you can see null: Maldives, India, Slovenia, Peru, Nepal. These are all basically there are 71 countries data is null, and 49 is because we have 49 days from from when the coronavirus has started, right? So basically the 49 values in each for each of the country. Now quickly, if you run the top 50 records, you can just visualize the output. You can see in case of Queensland, the Queensland is getting copied. There is an to be filled wherever there is a null, and if, in case there's a null here, but from the latitude and longitude I was able to find out the exact location, right? So basically you can see like there are a lot of values that have come from Google Maps as well, right? Now what I'm going to do is I'm going to pick another data set from a GitHub repo. The GitHub repo is over here, which is basically going to give me information on the country and capital. So that's so I'm taking that particular and creating a capital data frame. If you see the output, this is what you will get. You will have each of the country and you will have its capital. So wherever the data is null, I'm going to replace it with the capital value. But again, this will also not fix everything. I will go step by step. So in this case, in the country capital, what is going to happen is the United Kingdom as represented as United Kingdom semicolon England, because there is a North Ireland United Kingdom part also. So there's two things. So in the case of United Kingdom semicolon England, I'm just going to replace it as United Kingdom in this particular data frame, right? So that's what I'm doing over here. And then I'm basically converting all this country value into lowercase, so that, see, I'm going to use this as a lookup value. If you understand the concept of reference data and everything, this kind of reference data I'm going to look up so that I populate the correct value, right? So I'm going to make it lower case so that I can easily look it up. So if you see the output, this is how it looks like. It looks like as a country, capital, and type. And now I'm going to make country as an index value. So in pandas data frame, I can do a search of value, but that is time consuming. So if I index this column, it makes it fast for me to search it. So if I am going to index country, and once the country is indexed, basically what I can do is I can do a capital deal of dot locate and give a country name, and I am picking 0 columns because this will become index, this will become the 0 column. So if you see the output now for Algeria, I'm getting Algerius. So Algerius is the capital over here, right? So the look up in pandas, right? Now what I'm doing is like before that I'm just printing all the tbf again to see. Now in this case, now I created one more function called lookup capital, right? In the lookup capital, I am passing country as input, and then what I'm going to do is I'm going to go to capital df and locate the country. I'm doing a lower case because the input value that is coming from the data frame can have any case. So I'm doing a lower case so that I can match it. And in case if it fails, I'm just printing a TBF again. It can fail because some of the countries that are there in the coronavirus data frame is not clean. So I need to make sure like I catch the exception, right? That's why I'm catching the exception and I'm returning the value. Now I am coming back to here. What I'm doing is I'm just doing a lambda function again, and if the state cleaned is equal to tbf, only where there's a tbf, what you do is you call this lookup capital method, the function we created on the top, else just keep the state cleaned as it is because the values are already filled. You can quickly see the output. Okay, the lookup capital is not defined. Let me run that function. I forgot to run this function. And now if you see, it will just print the output, right? This is what I'm doing. So wherever it is there, it's going to like take the data and print it. Now, I'm going to, I'm not, see, I'm just printing it. I have not assigned it everywhere. Now, what I'm going to do is, I'm going to take the same function I defined on the top and then put it into the combined df state cleaned column. So I am basically running this. It's going to find a particular, take the country out of the value from the thing, and look for the capital, and then it's going to impute the capital in this case, right? If you see the output, we had 71 missing values on top. Right now we have only this much: 1 2 3 4 5 6 7 8 9 countries which has missing value. And the reason is, Iran is a country, but it says Iran Islamic Republic of. Now Saint this Saint Bartholomew, whatever, right? It's basically it's basically, I think, part of Vatican City. But it's coming separately. Occupied Palestinian territory is the is a disputed territory between Palestine and Israel, right? So that's why it's separate. Now we don't want to really touch a lot of this. Vietnam is, there's a space, so there is some data issue. We need to do some cleaning. So now what I'm doing is, I'm going back to my combined data frame, and I am replacing Republic of Moldova with Moldova, because Moldova is the country name which is available in our lookup. I'm putting this OEC as Vatican City. All right. I think the Saint Bartholomew is like a port where they were quarantined in the ship and everything, right? There's a UK as well. I'm putting UK as United Kingdom, but if we want, we can do a two-digit lookup also. But I'm not doing that now. I'm just doing it. Vietnam, I'm changing to Vietnam. Iran Islamic Republic, I'm changing to Iran, right? So I will do this, and I will again go and if you once I have done that, now you can see the output. Basically, the output as United Kingdom, Moldova, Iran, and whatever Vietnam, whatever we changed, right? So we are just changing the data frame. I'm going to run, say, the same function that we defined on the top, because now it may be able to find the country. Earlier it was not able to find, because the name was not defined in a very generic way. Right now I have made it clean. So now let me run the function again, and those columns will be fixed. Now you should see from 10 it is going to be only 1 2 3 4, right? There's only these 4 columns are basically there, where there has been some empty values, right? So now this particular thing is this is the output. Now what I'm going to do is, I'm the state cleaned column. I am still good. I will still have some TBF, because these 4 values are not fixed. So basically what I'm going to do is, in the state cleaned column, I am going to just take the state and then populate whatever country is there in state. Now I don't want to go and further clean it. Maybe I will handle it in my downstream application in this case, rather than doing it here. So I'm just copying wherever is TBF, just copying the same value. That's what I'm doing over here. So the state clean is TBF, just copy the country, whatever it is. So I'm just taking the country and copying it, right? So let me do this, and I'm just doing an output. Now everything looks fine. There is no issue output. We can save the data set, but we are still not done. So I will just show you why we are not done. Now I'm doing it, but see, when I pick the country equal to US, now the problem I'm seeing is, right, for everything there is only a single value, but only for US, you have the US, you have the city name, and you have the state name, Washington, right? You have 3 different values. Now how can I fix this thing? So I just want only the state name and country name. Maybe city name I will keep it. When I want to show in a map and drill down at a city level, I will keep it. But how can I do that? Now what I'm going to do is, I'm going to go to one more GitHub repo, and I'm going to go to the list of, basically this is the GitHub repo name, and then I'm going to pick the states. What it will have is, I will show you, it will have a mapping of a 2-digit state code. We can see on the top, basically you have WA, OH is Ohio, UT is Utah, right? CA is California, and then you have this 2-digit state code and the abbreviated code. That's what I'm going to use, and I'm going to set abbreviation as my index in this case, because I'm going to look up the abbreviation. So if you see, the output will be like this. Abbreviation is the index value, and state is basically your the actual value that we want to impute it. So to give example, if I pass AZ over here, AZ is Arizona, it will give me the full name Arizona. Right now, what I'm going to do is, I'm going to quickly take this and see. Basically, if I'm telling the country equal to US, what I'm going to do is, because it is separated by a comma on top here, I'm going to do a comma separated split, so it will give me like 0 and 1 index. So I'm just using the split function over here. So if you see over here, I'm just using the split function, and the 0 value is the city name. I am populating it to the city column. I am creating the data frame a new column called city, and then I'm taking the 0 value, which is the city name, and populating it. That is the first thing I am doing, right? And second thing I'm going to do is I'm going to convert the state column, right? So for that, I'm using a function again. In the state column, what I'm doing is, why once I get the state, I'm splitting it. I'm taking the first value, which has the 2-digit short code, WACA and all. The first is a 0 digit, which is the city, and I'm assigning to the city value in the data frame. And then I'm stripping any spaces, and then I'm calling the upper data frame dot locate based on the city name. I'm doing a upper because the data frame on the top is everything is upper, and input value can come either way. I just don't want to take risk. I'm doing it and assigning it, and if there is an exception, I just print it outside output, right? So that's what I'm doing over here. So this state is defined, and then I am going to the state cleaned column, and then I am I'm telling that the country US, because other country does not have a problem, only US has this problem. When country equal to US, I am just populating the state cleaned over here, and then I'm calling the function convert state and state cleaned, else I'm keeping the state because the state in this case is already cleaned. So let me run this, and if you see the output, you can basically see over here. Okay, you can see a lot of null values over here because this is the state column, but you clean a lot of things in the state clean, and you can see like the city column is also populated wherever it's US. So here you can see King County WA US. So WA is Washington. We are did a lookup and did a Washington over in the state clean, and King County is the city which is going into a separate column. So wherever the US, you may find a city as well, right? And if you print only US, you can see the output as well here. You can see like okay, Charlotte County Florida, FL is converted to Florida, then Charlotte County, right? Now again, if you now is the data set perfect, there is a few more issues, but I don't want to go more than this. The thing is, yeah, US is double counted, just remember this. Now you have an US aggregated view at a state, and you have a US view at a country and city level. So if you take from this data set, you will get a double counting. So you have to just drop the columns which has only state, right? That's a simple step, but that's it now. Like finally I'll just save it, and this data set is there. I will use this data set for some other purpose when I use it with my Twitter data, and I have one more thing, web scraping, which we'll cover in the next video. So for now, that's it. I will continue with my data science portfolio series, and just have a quick short video on web scraping to get you started. Thank you for now.